In this last video, we're going to expand what we did in the previous one and graph a system of three inequalities. So first we have the inequality y is less than 2. Remember that if you have an equation that looks like y equals some number, it's going to be a horizontal line. So we're going to go to y equals 2, and we're going to put a horizontal line here. Because our inequality does not include an equal sign, it's just a strictly less than sign, we know that our boundary line will be dashed. And then we need to pick up a test point like 0, 0 to plug into our original inequality to see if it's true or false. So if I put in a 0 for any x's or y's in the first inequality, there's only y's, but I would get 0 is less than 2, which is a true statement, which means I shade on the same side of the boundary line as my test point. So all of these points are solutions to the first inequality. The second inequality, y is greater than or equal to -1, or x is greater than or equal to -1 rather, is going to be a vertical line. Remember, if you have something like x equals a number, it will be a vertical line. So we're going to go to -1 on the x-axis and make our point. This inequality symbol is greater than or equal to, so there is an inequality here, which means that our inequality sign and then our boundary line will be solid. And we can use 0, 0 as our test point again because our line does not go through 0, 0. So if I plug in a 0 for the x, and then there are no y's, I'd get 0 is greater than -1, which is true. So I'll shade on the side of my line that includes the test point, which is everything to the right. And then we've got one more inequality to graph on top of this one. We've got y is greater than x minus 2. That is in slope-intercept form. So I can see that the y-intercept is at -2, which means I'm going to go to the point 0, -2 for my first point. I can see that the slope would be 1, which means from that first point, I'm going to go up 1, right 1, up 1, right 1. I'm going to repeat that. And I could also go down 1, left 1, down 1, left 1. That inequality symbol is a strictly greater than sign. So my boundary line is dashed. The points along that boundary line are not solutions to that inequality. And I could use 0, 0 again as my test point. And I get 0 is greater than -2, which is true, which means I shade on the side of my test point. So all of these points above and to the left of the green line are part of the third inequality. Now our final solution is the place where all three of these inequalities overlap. So the red, the orange, and the green. And that is in this very small triangular shape here, where all three shadings overlap. Remember that you have the choice of going back and making your final solution much darker, or you could also go back and erase any of the extra shading. It's probably easiest to make your work shading very light and then go back and make your final solution darker.